Today is all about word problems. Woohoo! Everyone's favorite. And the best thing you can do for any word problem is to draw it out. So, number 1, a tree 24 feet tall cast a shadow 12 feet long. So, you're about to find out why I am not an art major. Here's a tree. Here's the tree's shadow. So this is 24 feet. This is 12 feet. Brad is 6 feet tall. We want to know how long Brad's shadow is. Well, here we have a set of similar triangles because we have the angle from the sun. That's the same for both of them. And so what we can do, I can once again look at my scale factor and say, oh, well, 24 to 6, I can just divide that by 4, which means 12 to get to this missing length. We can also divide by 4, and we get 3 feet long as his shadow. Great. Look, we have more trees, because trees are nice. You don't necessarily have to draw the full tree. If you just want to go ahead and draw the triangle, you can. I have a tree which is 4 meters, with a height of 4 meters, casts a shadow that is 15 meters long. How high is another tree that casts a shadow that is 20 meters long? And so once again, I can look 15 to 20. Gotta multiply 15 by some scale factor to get 20. So I can find the scale factor by dividing 20 by 15. I think it's 1.25. No, it's 1.33333. So I'm just going to reduce that so I don't have to deal with the fractions. 20 divided by 15, divided both by 5, 4/3. So now we're going to take 4 and multiply it by 4/3 to get our answer. I get 5.33 meters. Okay, 3 and 4 are a little bit more complicated than just straightforward trees and shadows. So a girl is 160 centimeters tall. She stands facing a tree. So we're going to put the tree over here. The tree that is 360 centimeters in front of her. So in front of her, that means this length here is going to be 360 centimeters. Her shadow is 90 centimeters behind her. If the tree's shadow meets the end of her shadow, how tall is the tree? Okay, here's what this situation is describing. Is that I have a big triangle here, but I also have a small triangle here. Triangleception. So I got 160 and I got 90. We want to know how tall the tree is, and now I can do 90 plus 360 to get the base here, which is 450. So now we find our scale factor. See, so I'm going to go 90 to 450. 90 times some scale factor gets me 450. So I'll just divide those. And I get 5. I love when they work out nicely because it's so nice. So that means I can take 160 and multiply it by 5 give me the height of the tree. I get 800 centimeters. My tip here is to just draw a piece of the word problem as you get it. So that's how I did number 3. So I'm going to do number 4 the same way. Sonia is on a football field facing one of the goalposts. So I'm going to draw Sonia. And she's going to be facing one of the goalposts. She wants to know how tall a goalpost is. So that tells me that this length here is going to be x. So she places a mirror on the ground and walks backward until she can see the tip of the goalpost in the mirror. Okay, if you don't know what this is talking about, this is going to be confusing. So I'm here to tell you what's going on. Basically, you can create similar triangles if you were to place a mirror in between you and an object. You move backwards until you can see the tip of the goalpost in the mirror, and then it creates similar triangles between the mirror and you and the mirror and the goalpost. So that's what's going on. Sonia is 65 inches tall. She is 100 inches away from the mirror, and the goalpost is 830 inches away from the mirror. So how tall is the goalpost? So here are similar triangles. We got one here, and we've got one here. And so the sides that go together, 100 is going to go to 830. So 100 times the scale factor gets me 830. So I divide it by 100, and I get 8.3. And now we're going to multiply that 8.3 times 65. We get 539.5 inches. Okay, so the next piece is you're going to do an activity in class. And if you're not in class, you're not in class. So there you go.